Okay, hi everyone. If you're my student, you can take out your foolscap pen, pencil, and yep, that's all for now. If you're not my student, if you have any queries, you can contact me via my webpage in the description below. Yep, that's it. Let's start. So this is probably the second part of the organic chemistry. This is hydrocarbons. It's a sub part of the fuels, blah blah blah. Okay, so in the seventh part, this is the sub part of the first one. Okay, in organic chemistry, and it's just basically the introduction and basic concepts. And what you have to do is just memorize the definitions and the wordings. Okay, so first thing first, homologous series. What is a homologous series? It's a group of compounds with general formula similar, sorry, I missed the word similar, with similar general formula and similar chemical properties. So what I need you to recognize later on is that homologous series is basically the tables that I will be asking you to write down. Okay, so you can see in the later videos, but for now, just recognize this definition and you'll gradually understand what's going on. Next thing is you need to memorize the explanation for trans down homologous series. Okay, so from here, if you after reading the explanation, you'll realize that it's very similar to how group properties. For example, group one metals have similar properties. Group seven halogens have similar properties. This is also the same here. So homologous series is similar to a group in organic chemistry. Okay. Okay. So let's start. So the first thing first is you need to know that the Pauling mapping points DPMP increase down the homologous series. Okay, DPMP increase down the homologous series. Okay, why? You will say size of molecule down homologous series, size of molecules increase. Uh, intermolecular forces of attraction increase, and PVP increase. Okay, write that down. Okay, for my students, write that down. Okay, viscosity increase. Okay, why? Again, down the homologous series, size of molecule increase, intermolecular force of attraction increase, viscosity increase. So you realize the explanation is very similar to the first one. You can write two inverted commas if you are lazy, but it's fine. Okay. Then the third one is slightly different. Okay, flammability decrease. Okay, flammability means the flames have been more efficient, basically less smoky. Okay, so in this case, you will say the down homologous series percentage of carbon. Okay, C. You can write C because it's a formula for carbon. Okay, so percentage of C by mass increases. Okay, resulting in sootier flame. Sootier flame means small black smoke. Thus, flammability decrease. Okay, you can pause the video to write this down. Okay, and once you're done writing, you can continue. Okay, next one. Isomerism. So what is isomerism? It's the existence of molecules with same chemical formula but different structural formula, meaning they have same number of C, same number of H, or yeah, whichever, or same number of O's in the formula. Okay, but the way you draw the structure is different. Okay, so over here in organic chemistry, you will get used to drawing the structure. Okay, so again, isomers, which is a similar term, so molecules with same chemical formula but different structural formula. All these are stated in the syllabus that you're required to know. That's why I'm going through all these. So basically, you know the definition and then later identify, which will be in the subsequent videos. And finally, we are reaching the last slide. Here are some of the examples of isomers. Okay, so as you can see from here, this is the all three have the same number of C and same number of H. So they are called isomers because the C and the H are the same. Okay, so the molecular formula will be the same. It will be C5H12 for all three of them, if you can count. If you want, you can count on all of them. Okay, but you realize that their structures are drawn differently. Okay, how do we know the structures, whether they are drawn differently? You can start from any corner of the chain. You count. So there's 1, 2, 3, 4, 5 C's. And here I start from this corner, I count 1, 2, 3, 4. If I start with this corner, I count this way, I also get 4. So if the total number is different, then they are isomers. 1, 2, 3. No matter which corner I start counting, I'll end up with 3. Okay? So if the total number of C's you count in one direction from any corner is different, then they are isomers if they have the same molecular formula. Okay? And that's all for the introduction, second part for hydrocarbons for organic chemistry. Okay, next one is alkane. That's all.